Bismillahir Rahmanir Rahim. Starting with the name of Allah, the most merciful and beneficent. This is Hafiz Mehar Elahi, lecturer in physics, and today's my topic is X-rays. Before going into the further details, first talk about the definition. So we can define X-rays in such a way that these are electromagnetic radiations of short wavelength in range of zero point 0.5 angstrom to 100 angstrom, where 1 angstrom is equal to 10 raised to power minus 10 meters. First, we'll talk about the discovery. So, history tells us that the discovery of X-rays are accidental, and Roentgen for the first time discovered X-rays in 1895. Now, first we will talk about how X-rays are produced. So, you can see the figure. In figure, you can see the filament, which is one of the main part in X-rays production. The filament is connected with the high potential difference, and it is used to produce high energetic electron beam. These electrons will strike the target, and here the target is tungsten material. When high speed electron strikes the tungsten material, it emits radiation, and these radiation are called X-rays. This whole process is happening in evacuated chamber, which is called vacuum chamber. A coolant is here, which is used to reduce the temperature of the target. Now, the question arises, what is actually happening inside this tungsten material? So for this, we have to study inside it. There are two types of X-rays that are generated inside this tungsten material. So these two types are characteristic or inertial transition X-rays, and the second type is continuous X-rays, which are also called Bremsstrahlung. First, we'll talk about characteristic X-rays. Characteristics are X-rays are produced when incident electron collide with electrons of target material and knock out electron from inner shell, that is K shell or L shell, it could be M shell also. Then the electron from any other higher shell jumps to fill the vacancy, and as a result it emits radiation called characteristic X-rays. Now you can see the figure over here. You can see the electron from upside strikes the electron of the target and knock it out outside the atom. The electron itself scattered on the other side. Now look at the orange arrow. An electron is jumping from a higher shell, that is L shell, to K shell, and as a result it emits radiation, which is called X-rays. And these type of X-rays are called characteristic X-rays. In characteristic X-rays, when electron jumps from L shell to K shell, then the radiation will be called as K alpha radiation. Similarly, if electron jumps from M shell to K shell, then the radiation will be called as K beta radiation, and so on. You can see the graph, K alpha, K beta, and K gamma. K alpha is the radiation emitted when electron jumps from L shell to K shell. When electron jumps from M shell to K shell, then it will be K beta, and similarly from N shell to K shell, it will be K gamma. Similarly for L alpha, L beta, and L gamma, where the intensity of K alpha will be greater than K beta and the intensity of K beta will be greater than K gamma. Now moving towards the second type of X-rays, which are called continuous X-rays. And continuous X-rays are produced when electron passes near the nucleus without striking any electron and lose some of its energy due to nuclear force. That radiation is called continuous X-rays. These continuous X-rays are also called braking radiation or Bremsstrahlung. You can see the figure. Continuous X-rays are produced when electron is coming from outside, that is filament, and passes near the nucleus without striking any other electron, and it loses its energy and it bends it towards the other side, and as a result, because of this process, it radiates energy. So these radiation are called continuous X-rays, which are called Bremsstrahlung. It could be called as raking radiations. You can see in the other image, the more better image that can show you the electron is coming, passes near the target nucleus and lose its energy, and as a result X-rays are produced. There are some properties of X-rays which are as below: that X-rays are invisible, we cannot see that. X-rays have no mass, they are massless. X-rays travel with the speed of light in vacuum. X-rays travel in a straight line without any deflection. X-rays have very short wavelength, and X-rays can cause ionization and so on. Similarly, we have many uses of X-rays. Some of them are as below: that X-rays can pass through the blood and not through bones. Therefore, they are used to detect the fracture of bones. Also, X-rays are used to destroy tumor in human body. X-rays are also used to detect defects in rubber tires, tennis balls, or other materials. And X-rays are also used to detect cracks and holes in many materials. There are so many other uses of X-rays which could be studied. Thank you so much.